All right, welcome everybody to a new edition of NEXTEpisode, the podcast that talks about sustainable technology solutions. Today we're going to talk about hydrogen, which is the most abundant element in the universe, also very simple, H2. And it's a crucial element, a crucial molecule to decarbonize the industry. I'm definitely not an expert in this field, so I've asked Cristina Guazzotti to join us. Welcome, Cristina.
Thank you.
You are the head of technology solutions at KT Tech.
Yeah.
Can you maybe share a bit about your background before we dive into the hydrogen world?
Yeah, okay. Thank you, Mark. And I'm the head of technology solutions in KT Tech. And I'm here invited to speak about hydrogen, I think because I'm almost spent all my career on hydrogen field and technologies. I started working almost 30 years ago in KTI at the time. My background, educational background, is chemical engineering, but I started in KTI, and most of this period has been spent on the technology relevant to hydrogen.
Okay.
And now I'm responsible for all the technology that are part of the portfolio in KT Tech. That one is one of the company of NextGen Group.
Okay.
And most of this technology are relevant to hydrogen.
Okay.
Maybe this.
That's a good start. So hydrogen, I think, is has been around here. Comes naturally in the sun.
Yeah.
I think on Earth it's more difficult to extract. Yeah. If I'm correct, it comes from natural gas and then it's reformed.
Yeah. Exactly.
I think we've let's say industry is a decades old technology. So hydrogen has been made for a very long time.
Absolutely.
Of course, with the transition towards renewable energies, I think we see a shift towards more low carbon hydrogen.
Yeah.
How does that work? What's the other different technologies, or is it the same technology that has been adapted, or what are the flavors of, let's say, hydrogen technologies?
Yeah. In the time, in this period, hydrogen usage has been switched, remain mainly as a desulfurization agent in the refinery, or used for producing from petrol, from heavier hydrocarbon, smaller hydrocarbon. Now it's more moved to the decarbonization or a vector, an energy source, an energy vector, really, because it's not a source of energy for automotive.
Okay.
So the hydrogen, let's say, usage over the time, over this period in my career, has been changed. Okay. And now, for sure, and the technology that are linked to hydrogen production has followed this also this path.
Okay.
Because in the beginning, in the original, when I started to work, there was mainly what now is named grey hydrogen.
Yeah.
Means production of hydrogen from hydrocarbon using steam over a catalyst bed. But there was no, let's say, specific focus on the amount of CO2 that was produced by this process.
Okay.
Because this is an endothermic reaction, means that need heat from external source to take place over this catalyst. And this was performed using a furnaces, that is the steam metal reforming furnaces.
Yeah.
And means that there are flames inside, there are burners that are burning fuel gas or methane, and this produces CO2. And this CO2 through the stack is emitted to the atmosphere. At that time, there was nobody took care about this. And what was important is to produce hydrogen for need in the refinery or in the chemical industry.
Okay.
then now there is a new path, new process that are asking to produce hydrogen, but looking at technologies or solution that reduce the CO2 emitted to the atmosphere.
So that's a adaptation of the steam methane reforming, or is it something completely new?
Both. I mean, the steam reformer solution, the SMR, can be adapted to reduce the amount of CO2.
Okay.
I mean, for example, can be designed in order to burn partially or totally hydrogen, for example. So produce more hydrogen that is sent back to the furnaces. And this will reduce the CO2 because when you burn hydrogen, you produce water and not CO2. Or can be adapted in order to achieve what is named blue hydrogen by removing the CO2 and collecting this to be stored in specific areas. This is the way that normally is applied to decarbonize the process. So capture the CO2 and let's say store it
so it underground somewhere.
Underground somewhere. So this makes this process and the product as well, the hydrogen, blue. So this is the same SMR that is modified to produce this.
Or modern SMR.
Modern SMR. Or we can use different technology that apply different concept. One is the ATR, autothermal reforming, and the other one is the CPO, that is catalytic partial oxidation. Are two technologies that are part of our portfolio.
Okay.
And these are a sort of, different concept because the heat that is needed to have this reaction is not produced by this burner that are external, to the catalytic bed, but is something totally integrated. Okay. So the oxygen that is used in the ATR, autothermal reforming, is burning, the hydrocarbon, and the heat that is provided by this reaction, by this mixture, within a flame, is the one that provided to this equipment in which is also installed the catalyst bed, enough heat to produce hydrogen, so to transform the hydrocarbon in hydrogen. What is the advantage? That there is no furnaces. This is a vessel. Let's imagine as a vessel that need also only a small heater in front to preheat the mixture that is introduced in this vessel. So starting from the SMR, we have a smaller heater in front, means we have less emission of CO2 to the atmosphere. Okay. The further step of decarbonization, reduction of CO2, is use the catalytic partial oxidation, the CPO. That is another technology part of our portfolio, in which there is no burner. So, the heat needed to have the reaction over the catalyst bed is produced by the contact, the mixture of oxygen and the hydrocarbon over a very active bed of catalyst that is auto-producing the heat needed to have this reaction. And this means that we don't need even the furnace in front to preheat this mixture. And this will reduce further the CO2 emission to the atmosphere. So, as you see, is a sort of step of improvement that can be done on the SMR modifying heat or changing totally the technology.
It sounds like you're going to reduce or remove the furnace. So does that also mean that the investment, the capex is reduced?
As well, depending But there are other factors that are linked to the capacity.
Okay.
So because this technology cannot be applied on complete range of capacities, and so means that there are areas or segment of capacity application in which each technology is the best solution to be applied.
Okay. Can you give a range for each of the technologies? What sort of what's the max capacity?
The CPO, the catalytic partial oxidation, is the solution we use to small up to medium size range. Means generally up to 50,000 normal cubic meter per hour of hydrogen production or equivalent hydrogen production. Then there is the steam methane reformer, the SMR, that can range for small capacity up to around 200,000 normal cubic meter per hour.
Okay.
So it's feasible technically, but the best is 115,000 normal cubic meter per hour.
150.
150,000 normal cubic meter per hour. And then for higher capacity is for sure the ATR, the technology to be applied.
Is there a max limit to the ATR